than, I mean, I don't know, less than
10 months.
just a few months.
10
Okay,
months.
just 10 months. Amazing, all the results that Billy sir just said, that 3,000 people uh, educated, so many hours of content placed online. And we have the hackathon now. We have a special course going on for
Students.
APSCHE and students and everything. So amazing, So thank you so much, everyone who's been participating. And this is just the beginning. Only in 10 months we have achieved this. Now imagine what's going to happen in the future. So we have to do this, sir. And January, this hackathon we must conclude. Yes, sir, and get the CM and do it. And then keep on doing these QT series. Keep doing that, because now, so I was in RGUKT, the Nusvid campus, just 2 days back, and there, the students. So we are observing that the students' level has already gone up.
Okay.
So they are now looking for new, bigger projects to do. Okay. So as faculty, it's our duty now to make sure we give them those right problems so that they are able to, go and become world class.
Right.
Yes, sir. So
Yes, sir. You
today's
can take over, sir. Yes.
I'll take over now.
Sir,
So,
sir, one more thing I want to tell you
yes,
all.
sir.
Most of our colleges, they have called for the presentation on the UZ labs, sir, quantum UZ labs. On 5th, from 5th onwards, the JNTU, University, RG, even RGKT, all these colleges are called for interview, online interview. So they will present there, and we hope that at least 20 of from Andhra will get the UZ labs on quantum. Once these UZ labs are in place, definitely the ecosystem will be
Yeah.
very
NQM
dynamic.
UG lab.
Yes.
NQM UG lab proposals. Yeah.
Yes, sir. Yes.
Those.
Yes.
Sure.
Thank you,
Sir.
sir.
Thank you.
That's also very important, because now as we get into the bigger QT numbers, you need labs for them. It's important. So we must do this. Yes, sir.
Yes.
Thank you,
Sir.
sir.
Thank you, sir.
Yes, sir. So today's talk is about quantum advantage. Okay, so that's what we are going to discuss today. I will start sharing my slides. Okay, so just give me a minute. Okay, so today's talk is about quantum advantage. Okay, so we are going to discuss what is quantum advantage, and beyond quantum advantage, what is there. So you have all been taking these courses for the past several, weeks. And this particular course you began a few days ago, and you are now concluding. So what is this that you have to achieve out of this? What is quantum advantage? There have been several claims starting in the year 2019, and this is the year 2025. So what is this quantum advantage future? How can you participate? What is your role in this? What are you going to do? So that's our discussion for today. And please feel free to write in the chat, or I don't know how you'll ask questions, but I really would like that, you all ask some questions. Okay, so I'm just typing hello, quantum world. So I hope you can see this, and please type your questions at any given point in this lecture. You can type some questions. That's how we want to discuss this, and that's how we will learn. All of us will learn together. Okay, so that's our goal today. Okay, so then in 2019, I don't know how many of you are aware, there was this Google's quantum supremacy experiment was shown in that year. This was the year 2019. Okay, 2019, they said that using their 53 qubit quantum Sycamore processor, they executed what was called the random circuit sampling task in 200 seconds. Okay, so that's the amount of time that the Sycamore processor took. And this estimated time on a supercomputer at that time was 10,000 years. If you were to do this same random sampling task, not on a quantum computer, but if you did it on a supercomputer, the best supercomputer that is there, it would take 10,000 years. Okay, so this was the claim. Of course, many people then ran these experiments on supercomputers and they came back saying that it can't be done in 10,000 years. It can be done faster than 10,000 years. But the main thing here was that this experiment started this global pursuit of practical quantum advantage. So it was shown here that there is a task called random circuit sampling on which these quantum computers are so much faster compared to the best supercomputer. And this got picked up by all the news channels, by all the faculty and students. And because this was the first demonstration of quantum supremacy, where a quantum circuit was outperforming anything that a classical supercomputer or the best computer can do at that point of time. Okay. And this, as I said, catalyzed so much of this global pursuit for practical quantum advantage. Okay. So that's what happened. So this began this race to say that, okay, what can we do using the quantum computer, which you cannot do using classical computers? Okay. So since then, have you heard of other experiments that people have performed? Okay. So we are going to talk a little bit more. And as I said, please put your questions, comments, whatever you like on the chat. Okay. Keep doing that. So since then, that was 2019, that Google experiment. And then the Chinese Zhu Shangzi quantum computer, this one, starting in 2021 up to 2025, they now hold the strongest claim for quantum computational supremacy. Okay. So I think again, Google came back with new experiments using their 105 qubits. But at this point, they showed that their computer was millions times faster than the Google results. And they were able to do experiments which were, even in terms of complexity, were orders of magnitude higher than the Google one. Okay. So as I said, 2019, this race began where people started saying that, okay, I'm going to now start showing experiments on a quantum computer, which you cannot run on a classical computer, that it is so much faster on a quantum computer. So the Google experiment showed that first, then the Chinese got into it saying that here is this Zhu Shangxi computer, which can do even faster than the Google results. Now, I want all of you to go and check on ChatGPT or on Google or wherever you like to go and understand what is this random circuit sampling. Okay. At a very high level, I'm going to explain what random circuit sampling is. A random circuit is a quantum circuit which you build using a random chosen number of quantum gates. Okay, you all have probably by now built these quantum circuits. You all know what are quantum gates. Okay, so here you build quantum circuits using randomly chosen gates. Okay, that's what you do. And you run these circuits multiple times, many shots. Okay, you run it many times, and then you collapse these into the bit strings, outputs of 0, 1, whatever, those random circuit things are going to create. You create this, distribution of all the possible outputs that you are generating. And the goal is to match the probability distribution that is predicted by quantum mechanics. Okay, so quantum mechanics will predict, you can mathematically show that what are these possible probability distributions, and you try to match this using the quantum computer, right? Now this circuit is random, and hence a classical computer struggles with this. It there is there is no structure because it's all randomly chosen gates. Okay, there are no patterns, there is no symmetry that you can exploit. Hence what the supercomputer or the best computer, it struggles to do this task. Okay, whereas the quantum computer, it is able to do these, the prediction of these distributions. It's able to do it much faster. Okay, so as I said, please go and look up random circuit sampling. Also look up what the Google experiments have been. So they started in 2019 with the Sycamore processor, the 53 qubits. And since then, they have done this again, okay, 2025, using the Willow processor, okay. And the Chinese have also been running on their Zhushangxi computer. And there has been this competition to show that the random circuit sampling task, you can do this on a quantum computer much faster compared to a classical computer. Okay, so that's what this one is. And why does this random circuit sampling RCS matter? RCS is one way to probe whether a quantum processor is doing something which a classical supercomputer cannot do efficiently. It cannot reproduce this efficiently. So that is why it is tied to this quantum supremacy claim. Okay, that's why people are claiming that, okay, using this random circuit sampling, which I am not able to do on a supercomputer or the best computers that are there, I am able to do this very fast on a quantum processor, because the quantum processor produces a distribution much faster, okay, than and it's able to consistently match the theoretical quantum prediction. What you predict mathematically using quantum mechanics and what the quantum system is producing, it is able to match, okay, very quickly. But the simulating this on a classical computer becomes infeasible as the circuit sizes keep on improving. Okay, and that is why we say that this demonstrates quantum supremacy, because here is a task which you can run on a quantum computer, but you cannot run with the same speed on a classical computer. So, as I said, I've given you a high level understanding of this. What is random circuit sampling? What did Google do? What did the Zhushangxi computer do? And now please go and study this more to see, can you run this on the quantum computer yourself? Okay, you can also do this. You can run this on the quantum computers, the quantum simulators that you have. You can run this and test this, and you can see the results for yourself. But for smaller circuits, the classical computer will be able to do it. But as you make it bigger and bigger and bigger, the quantum computer will run off and the classical computer won't be able to match it. Okay. Now, IBM has been saying that, okay, what is this quantum supremacy? we should really be aiming for quantum advantage. Okay, so what is quantum advantage? And I will come to that also. But IBM in 2023, it showed that, okay, you showed on random circuit sampling, which has very little or no practical value. Nobody has been able to say what is the practical value of that. Okay, so IBM said we are only going to pick tasks where there is some practical value, where there is some business value to the problem you are solving. And when we solve that, that will be quantum advantage. Okay. So in 2023, IBM showed what it called IBM quantum utility, where they showed that using a quantum computer, you can run quantum circuits beyond what you can simulate on the best supercomputers. Okay. So we will come to what that is. So they said that using quantum utility, you are now showing that quantum computers are already doing certain things which you just cannot simulate using even the best supercomputers that are there. Okay, so they ran the experiment on a quantum computer, on a supercomputer, and they showed that beyond a point, that matching is not, I mean, the classical computer is no longer able to simulate as the complexity of that problem keeps on increasing. Okay. And they said, quantum advantage will be when we are able to actually show that quantum computers can solve problems much more accurately, much more cheaply, or much more efficiently compared to a classical computer. And this confirmation will happen through a real world usage, a problem which is of value to somebody. Okay, so that's the argument that IBM made to say that, okay, quantum supremacy, you're doing something with random circuit sampling, but what about real problems in the real world? How do we solve those? Okay, and that's when we will say quantum advantage has been achieved. Okay, so that's what this was. And any questions so far? Okay, I'll just see if anybody asked any questions. Okay. Okay, no questions so far, but please ask questions. Okay. Yes, and that simpler terms, we are coming to that. Okay, so the question is, can we say in simpler terms what is quantum advantage? Okay, so that's the utility. Okay, utility versus supremacy. Okay, supremacy is you show any problem, whether it is useful or not, you don't care. All you care is the quantum computer is doing much better than the classical computer. So that is supremacy, where you're saying that I pick any problem, whether it matters or usefulness is there or not, doesn't matter. We are going to show that the quantum computer is faster at running that task. And that task they picked was random circuit sampling. Okay. No one has been able to say why random circuit sampling is an important problem. Then IBM says quantum advantage has to be shown on a useful problem, not on something like random circuit sampling, which people don't know what the value of that is. We have to show it on some problem where there is value. So that is that's the sort of the definition difference between supremacy and advantage, though people use it interchangeably also. Okay, so anywhere where you are able to show that the quantum computer is able to solve a problem much faster compared to a classical computer, or you are able to do it much more cheaply, or you are able to show that it's able to solve much more efficiently, people have been interchangeably using the term quantum supremacy and quantum advantage there. And the claim here is that quantum advantage will come at different times in different domains and depends on the the continued advancement of quantum algorithm implementations across industries. So, in real world usage, what are those problems where you are going to show that the quantum computer is much more accurate, is much more cheaper, or it is much more efficient? And which are these industry or real world usage problems where you are going to show this? Okay. So now, okay, was there? So on this path, there have been multiple things which have happened. Okay, so 2023 is when quantum utility was shown, the first paper. So we'll talk a little bit about that quantum utility. And then 2024 and 25, people started bringing quantum centric supercomputing. What that means is you are now bringing HPC and multiple quantum computing processors together to show that they are able to work together. Okay, so all these are able to basically QPU, CPU, and GPU are able to work together, and that has been shown last year and this year. If you look at the research work that has been done, a lot of people have been showing that this quantum centric supercomputing idea, where they're bringing together multiple quantum processors and HPC to show that you are able to do certain things on this. And then 2026, next year, is when IBM is saying that we are going to demonstrate quantum advantage. And remember the distinction between IBM's definition and the supremacy definition has been that you are going to run some computation task which is of a real world task, okay, a real world task usage. You're going to show real world usage and show that the quantum computer is able to do it either much more accurately, much more cheaply, or much more efficiently than a normal classical computer. And the date which has been put on this is 2026. So starting tomorrow, anytime, you should be able to start demonstrating quantum advantage. Okay. Now the big question is, who is going to demonstrate that? And then 2029, 3 years from now, is the time we will get to see fault tolerance, large scale quantum computers capable of correcting errors in real time. Okay, so that's the 2029. You're going to have fault tolerant quantum computers. Now, I want us to sort of step back a little bit to understand what do we mean that in 2026 we will reach quantum advantage. Okay, so on the chat I want you to write now that when was PCs, when did PCs come out? Anybody know when the personal computers came out into this? I mean, when did PCs become available? Yes, 1970s is when the mini computers, mid 70s is when they became available. Okay. But for a long time, PCs were not used by people. Okay, many people were not using PCs. Who made PCs such that PCs became very much usable, and it became much more popular? When did PCs become popular, and who made them popular? Yes, so in the 1980s, Microsoft came out with operating systems. It came out with tools like, you know, uh, so MS-DOS, yes. In the 80s, MS-DOS came out. Microsoft came out with MS-DOS. And what happened was, after that, people started using the PCs because once you have the operating system, you are able to, easily interact with the computer. People were able to make, games. People were able to make things like tools, like productivity tools, like Word, Excel, PowerPoint, and all these things. So only after that operating system came out, the PC, which had been there for several years before that, was not a popular thing until somebody came out with that software or came out with that easy to use interfaces, which was the MS-DOS, and following that the Windows. And these were all the tools like, Microsoft Word, Excel, and all these things. So until then, PCs were not usable. Okay, they were there, but they became useful only when people made it so much easier with these usability things. And then World Wide Web. When did World Wide Web come out? So 1983, the World Wide Web was, it came out in CERN. But does anybody know when did World Wide Web become useful? In the 90s. I don't know how many of you were born then or whatever. In the 90s, people would buy PC, but they would not buy internet connection. Yes, World Wide Web existed, but who made World Wide Web usable? Two things made World Wide Web usable. Of course, Wikipedia, somebody has typed Wikipedia. Wikipedia came a bit later. The search engines, Google was one. Before search engine, if I had to look at the MNIT website, I would have to call up Pilli sir and say, sir, what is your website address? So just like you share your phone number, I would have to call somebody and say, okay, what is the APSCHE website? And you would tell me www.apsche dot whatever, that's how you would tell me. So before search engines, there was all that data on the web, but we did not know how to reach that. You had to call up everyone and say, okay, please tell me what is your website ID so that I can go to that website. So 1983, no, and it took about 15 years later when Google came out with the search engine that the usefulness of the World Wide Web came out. But even more useful than Google was one more thing, which was the browser. So a company called Netscape created the world's first browser. Okay. Before that, now don't use your browser. Try going to the internet. Yes, email is also one very important discovery. Yes, so email, search, browser. But two key things I think were, number one was browser. Before the browser, nobody knew how to go to websites. You had no clue. The second thing was the search engine. Before the search engine, if you had to go and search for any website, There was no way to search for it. You had to call that person and say, okay, please tell me what is your website address so that I can type it and go there. Okay. So these were examples of, so you can call that web advantage, like quantum advantage. Web advantage happened after search engine, after browser, after email, after Wikipedia. That is when web advantage happened. You can say PC advantage happened when after the operating system came out. Before that, it was too difficult to use the PC. You had to be a great scientist to use the personal computer. But after the personal computer got the operating system, Microsoft came out with the world's first operating systems for personal computers. After that, everyone knew how to use the personal computer. After Google and browser, the Netscape browser, everyone knew how to use the internet. Everyone knew how to search for things. And that became the most used things in the world, the browser and the search engine, two things. Then AI. AI came in the, I don't know, AI came in the 50s, 60s. But what made AI popular? Who made AI popular? Like Microsoft made PC popular, Google and Netscape made internet popular. Who made AI popular? OpenAI, yes. OpenAI with its chat GPT, which everyone uses today. It was only after chat GPT came out that everyone started using AI. Okay, so everyone started using AI after the advent of chat GPT. When people started to use AI, AI came to all our mobile phones. So AI came to the desk of everybody's desktop. So it was only after this OpenAI's chat GPT that AI became popular. Otherwise, AI came in the 1950s, 60s, 70s, 80s. AI was there, but no one was, only scientists were using it. After OpenAI's chat GPT, everyone, all the common man or common woman, common child, everyone started using AI. Okay. So now quantum advantage is actually that, where you use the quantum computer of today to show what can you achieve using this quantum computer. Is there a problem you can solve which is much faster, much more cheap, much more efficient compared to what you can do on your classical computer? So that's when we can say that quantum computer is actually useful. Okay, when you are able to show some quantum advantage, just like we showed AI advantage, we showed PC advantage, we showed internet advantage, we are now waiting for that quantum advantage. Okay, and that's why IBM says that you showed supremacy using some this random sampling, but where is the usefulness of that? Are you able to use that to solve some problems which makes quantum more usable and for people to more popular and more usable after that? Okay, so that's what we are waiting for. And as I said, the date that IBM has given is 2026. There are other startups which have also given some other dates, so you can also look them up. But it is all beginning to happen now. Okay, it's beginning to happen where people are saying that now we are going to show some results which you cannot show using classical computers. Okay, so that's, we are now entering that age of quantum advantage. Okay, so as I said, in 2023, IBM showed this quantum utility. Okay, so IBM researchers ran on the quantum computer. UC Berkeley, University of California, Berkeley people ran the same thing on the best supercomputers available to them. And what was shown was that the quantum computers can produce accurate expectation values that go beyond what you can do using a simulation on a classical computer. Okay, so quantum computers running quantum circuits beyond the capability of classical simulation is what IBM called as quantum utility. Okay, so in this, what did they do? They used a 127 qubit quantum processor, the quantum eagle, and they ran a time evolution many body physics system which involved 100 plus qubits and thousands of quantum operations on a quantum computer. And they compared this with the best classical methods for the same problem using the best supercomputer available to the researchers at UC Berkeley. Okay. And what was shown was that the quantum system reliably produced accurate results even at points where the classical simulation was extremely difficult or it was not even possible. Okay. So what are you doing here? You are now picking up a sort of a real world problem, a many body physics problem, and you are running it on both the classical and the quantum, just like the random circuit sampling experiments, and you are showing that you're able to produce reliable results. Okay, and these reliable results, one of the important things is you can't just say that, oh, I ran it and it is better. You actually have to verify by comparing the results that you get on a quantum computer with the exact classical simulations where it is possible. But remember, we are saying simulation, it's not possible beyond a certain number of qubits. So then you now resort to the best approximation methods mathematically. Okay, so you are now trying to use this, you're running multiple runs and then calculating these expectation values, and you are now seeing whether this is in agreement with quantum theory. Okay, so that's how you're doing your verification. So remember, you can do the experiment on classical and quantum, and on quantum you have to show that it is much faster, much more efficient, much more accurate, or whatever. That's what you have to show. And then you have to show that the results that you are obtaining, they are verified as being correct. How do you verify? You have to check mathematically and statistically that whatever you have now produced, those results are actually accurate. So that's what you need to do. And that's what the people who have been showing both supremacy and people who have been showing this advantage, this is exactly what they are demonstrating. They are demonstrating that on the quantum computer, you are now getting into places where the classical is no longer able to simulate. But at the same time, you are now showing that the quantum result that is getting produced, which is getting produced, you can't even do it on the classical computer, is actually correct. Okay, so that's what you have to do. And to do that, you use statistics or you use exact calculations using quantum mechanics, okay, or quantum theory. So that's what this is, right? So that's what you're doing here. And as I said, 2026 is the year of quantum advantage. Okay, that's the year when we expect that quantum advantage will be shown. IBM has put its word that we are going to show this. And there are many, many teams across the world which are now engaged in trying to do this. Okay, and this is what we want from India also. We want to be able to show that quantum advantage comes out of India. We want to show that, like Microsoft for PCs, like Google and Netscape for internet, like OpenAI for AI, for quantum, the ones who bring out that quantum advantage have to be people who are here in India. And that's one of the goals of this FDP program, which is to train you so that you are now able to solve real problems on real quantum computers, which you can then go and run and get the results, and you are beginning to show quantum advantage. Okay. So, quantum advantage is achieving computational tasks faster or more efficiently than classical computers, where you are using quantum properties like superposition, entanglement, interference to actually achieve this. You're trying this in multiple domains like quantum optimization, like chemistry problems, like cryptography problems. So, it's not only about speed, it's about efficiency, it's about new capabilities, and it's about creating this new milestone where you are able to demonstrate practical value on a real world problem, whether it is an optimization problem, whether it's a chemistry problem, whether it is a cryptography problem, or it's an AI problem. In all of these, the goal is for you to now show that the quantum computer is much more fast, much more efficient. It is able to go and solve problems which you cannot solve just by using a classical computer. Okay, any questions so far? Okay. So now, as we said, the definition of quantum advantage is under this, you are now saying that quantum advantage is where you are able to run some business task or some use case much more efficiently, much more accurately, and at a lower cost compared to the best known purely classical approach. Okay. And in the last few months, people, what they have been doing is to combine the power of quantum and GPUs or CPUs, put them together and try and solve problems which you cannot solve alone using just the classical infrastructure, and saying that by putting these together we are now able to do much better, much more accurate, much more efficient, lower cost. So that's what we have to do, and we have to do this in a provably measurable way. We have to show that there is advantage and I can measure this advantage. It's accurate. What I have done is correct. I can measure it. I can what I have achieved here can be verified. So that verification is something that you need to do. Okay. So the core criteria for saying that I have achieved quantum advantage is correctness, which is verifiable. So the quantum result must be confirmed as being correct. You must mathematically or statistically, we have to show that the result that you are claiming that you achieved on a quantum computer is correct. And this is very important because now you are saying that the classical computer can't do it. So then, if it can't do it, you cannot compare against the classical output. Okay. So hence, you now have to say that, look, I'm now achieving accuracy which is verified. The second is there must be a clear separation which you must be able to measure. The quantum computer must be able to demonstrate a clear performance benefit, whether it is in terms of speed, cost, precision, resource efficiency. But you must be able to demonstrate that if I just used a classical computer, I would not be able to achieve this. I can only achieve this because I am using a quantum computer. So that measurable separation and verifiability. These are the two very important conditions, and together these criteria turn quantum advantage into a scientific hypothesis now. So you are saying that take a problem, whether it is in chemistry, molecular simulation, whether it is in optimization, whether it is in search, whether it is in artificial intelligence, in all of these, I am now comparing with best known classical results on the quantum computer, and whatever I am achieving on the quantum computer, I can now show that this is correct, this result is correct, and this result cannot be achieved by just using the classical computer. Okay, is there a question? Sir, when can we experience in all walks of life, especially that supercomputers are not able to solve, but quantum able to? So, when in all everything, no, we'll never achieve that, because quantum is only going to be good at certain tasks. You take multiplication. Multiplication is much faster on a classical computer. So you are not going to achieve everything faster on a quantum computer. No, it's not going to happen. Quantum and classical computers will continue to work together, but on certain problems, the quantum computer will show much better results. Okay. And as I said, that result we don't know yet, but it is expected that it's going to happen by 2026. People are going to begin showing those results. In fact, we are not able to do it. So molecular simulation. Okay, we'll come to what is molecular simulation. Okay, so now I'll come to this question of what is molecular simulation, what is route planning, all of these questions. We'll just come to that. As an example, a route planning can be that um, Indigo. Indigo has, let us say, 300 aircraft. Just an estimate, okay? I'm just putting some number. It has 300 aircraft, and now in a day, let us say Indigo flies to 7,000 destinations. Okay. So in this, what is the best, most efficient way to take these 300 aircraft and make them fly to these 7,000 destinations across India in a way that minimum fuel is lost? Okay, so you can, for example, you can say that I will put aircraft which will go from Delhi to Chennai, it will come back to Delhi, then it will go to Surat. So there are multiple ways in which you can route these aircraft. Now the task here is, how do you route these aircraft in the most efficient, cost effective manner? And this, as soon as you cross about 10 aircraft and a few airports, this becomes a combinatorially explosive problem. Okay, you're no longer able to do this. The best supercomputer cannot solve these kind of problems. So that's what is route planning. Molecular simulation is, you take a molecule has atoms, it also has electrons around it. For one fraction of a second, can you estimate the state? Basically, where are the atoms? Where are the electrons? Where are all the atomic and subatomic particles within that molecule in a given fraction of a second? That problem is called molecular simulation, the minimum energy state in which the two atoms are steady, the electrons are all happily spinning around, and the two atoms are not breaking apart, or they are not doing some fusion or fission or whatever reaction is happening there. So that is called molecular simulation, and to be able to do that, that again is a problem which you cannot solve on a classical computer. Okay, now now On coming back to this quantum advantage, so there is a website now called the quantum advantage tracker.github.io. Okay, so you go to GitHub, type or go to Google and type quantum advantage tracker, and it will take you to this website. This is a community driven effort. Anybody can go and put any problem they like there, and they can solve anything they like. And the goal here is the community is going to collect all the possible problems that people are solving, and also validate and compare electrical, the experimental results, and say that here, if somebody says, one of you achieves quantum advantage, you can go and put this there, whatever you achieved, and then people would come and validate. You can think of this like the Wikipedia for quantum advantage. In Wikipedia, you go and try to change something. You go and say that, okay, Japan is the capital of China. Let us say you go to the Japan page on Wikipedia and change that capital city of China is Japan. Within a few minutes, people will come and say, no, this is wrong, and they will correct it. That is what is an open community driven effort. You can put anything on Wikipedia. Many people will be viewing that, and if they see some errors or something, they will actually make some changes there. Okay, so you can also in fact go today to Wikipedia. You can go to the quantum pages there, your favorite quantum page, and add something today. You've been doing this course for a while now, and you're about to complete this course. So please now go to Wikipedia and see what you have learned, and is there something you can add to the Wikipedia page, something which is not there at this point of time on Wikipedia. In any of the quantum pages, you can pick quantum advantage, you can pick quantum um, qubits, pick whatever you like. Okay, and see, you read through that and then see, okay, something is missing here, I can add. Please go and do that. Okay, and this quantum advantage tracker is like that, where people can say that, look, I have achieved quantum advantage. People will then come and dispute that, or they will support you. So that's what this is. But you have to actually run experiments, you have to show results, and as I told you in the previous one, you want to have verifiable results which can be validated, and there must be a measurable separation to show that what you have achieved cannot be done using the best supercomputers, and there is actually a speed or a cost or a whatever accuracy, one of those things on those parameters, you are doing much better. Okay, so that's the goal here. And this benchmarking quantum advantage is that website where you can actually go and track things. And this is where, whoever says that in 2026, I I think I got disconnected. Can you hear me?
No, no, sir. You are not disconnected. You are visible and
I'm back. Thank you. Okay. So somebody put something on chat, I think. Okay. Can you please explain one general basic question? Why did we not study all concepts studied in quantum computing while doing classical computing, applying classical? I am a non-IT person. Non-audible. Okay, I'm back. Yes. So I don't understand this why you did not study. So okay, I also did not study, but these days I go and study them. So I think all of us now need to uh, go and study some of these things because they are probably new to us. Okay, and that's why some of the concepts I'm talking about today, like quantum advantage, all of these things might be new, but please go and spend some time to go and study these things. I am non-IT person. Okay, for non-IT person also, it's the same whether you are a IT person or anything. Please go and you will have to put some effort into learning these concepts. Okay, whether it is quantum advantage, whether it is, in fact, what is quantum, what is a qubit, what are these experiments we are talking about. So you have chat gpt as your friend. You can ask it any number of questions, uh, expecting answer like abstraction. Okay, I still don't understand what that means. Abstraction in quantum classical. Okay, please explain more what you mean by abstraction. Okay. uh, Okay, so researchers can assert quantum advantage, but they must show that with comparable baselines and validated results. Okay, so that's something that you need to show, and that's when you can achieve this. And this will help the whole field to progress forward, right? So now, to achieve this quantum advantage, in fact, that question is a good question because it shows that we all need to work together now. Whether I am a classical person, I am a finance person, or I am a molecule person, chemistry person, or a biology person, there is now a need for us to come together to solve build these real algorithms for real world use cases. So if you think that, for example, we are going to be able to solve the indigo problem by helping them to plan their aircraft better in a way that they are able to cover more number of cities with fewer aircraft, that is now an optimization problem, and that is one problem you can try and solve. Similarly, you can go and try and solve molecular simulation or any such problems, right? And more recently, HSBC demonstrated that in bond trading, they were able to show 34% improvement in predicting the probability of the winning customer inquiries in the European corporate bond market compared to the classical results. Again, please, I encourage you to go and look up some of these examples which I am giving. Why are people getting so excited about these results? So the day this result came out, IBM stock price went up actually. So the IBM stock price goes up because this 34% improvement in predicting this bond trading optimization problem they were able to demonstrate. So now, we come to India. Okay, in India, one of the key things here that we have is the talent. So as you might have seen, Pilli sir saying that thousands of people have already been trained on the QT courses. No other country has been able to do this. Okay, this is the largest training program in the world that is happening. No other country has so many faculty who have gone and so many hours, taken tests, listened to lectures, and are now going to go and teach their students, which is what you are going to do. You're going to now go and teach your students. And as a single large country, European Union, remember, is multiple smaller countries. India, as one large country, has the largest number of number one graduates connected to quantum technologies. You look at the IBM systems, the quantum systems, users. You look at the training programs like this FDP. India is now attracting more talent, more people who are now getting skilled in quantum technologies, where people are able to understand and learn these things and begin to actually use quantum computers. That beginning has happened, and right now India is the place where maximum such numbers are there. People are actually doing this more here than in any other country. So more talent is getting generated out of India compared to any other country at this point of time. Okay. And hence, that also means GST, okay, I don't know why I put the text here, okay, but I think the color. But anyway, the National Quantum Mission has been giving money, in fact, it money to all these 43 institutions across the country. 6,000 crores is the budget of the National Quantum Mission. So they are now, giving money for research into these topics. They are also, there is a new call, as sir mentioned at the beginning, there is a call for quantum labs across the country. There is a call for quantum algorithms and things happening. Things like startups. Multiple startups are getting created. Multiple startups are now getting formed in Andhra itself in quantum computing, quantum technologies, and these are also getting funded under the National Quantum. Happening. A lot of people are now entering into this, and there is a minor program which has started. And again, Andhra is one of the. Okay, am I? Can you hear me?
Sir, audible.
Here network problem, so I assumed some problems there. Okay, so the minor program getting are now will now be going and teaching these courses to your students. Okay, and this is happening in India at a scale which is unprecedented. No other country is happening. This is happening. The IBM Quantum System 2 is also going to come to Amravati, the Quantum Valley Tech Park in Andhra Pradesh. So by this year, in the year 2026, this quantum computer will also be placed in Quantum Valley. In fact, 2025 itself, IBM and Tata decided to bring this system, and the building for this system has now, I think in the next few days, there is going to be a foundation that, and the building will then start getting constructed. And once that building is completed, the IBM Quantum System 2 is going to be placed the Amravati Quantum Valley. Okay, so that's going to happen very soon. And the algorithm going to be an algorithm center which is going to come up there. There is also going to be hardware which is going to come up there. So you can run algorithms, but at the same time, if you wanted to see a quantum computer, open it up, feel what is inside, you know, test its components. So a reference facility where you can actually design and these things, you will be able to calibrate and standardize hardware components. That is also going to happen. Okay, so that's also going to happen in the Amravati Quantum Valley very soon, right? So 2026, in fact, the reason why you are all getting trained now is so that once the systems land, whether it is the software system or algorithm or the hardware, position to go and start you. That's the real goal of this. Okay, the goal of this is for you to go and start using these facilities so that you are now trained. And that's why it's important for you to skill yourself, to ask all the questions, even after this class. Go ask all the questions on internet and you will get the answers. The goal here is for you to prepare yourselves so that you are able to use this system, which is only available in a very few countries in the world. Okay, so Andhra Pradesh is going to be places where this is going to be available. And hence, you are now going to be in a position where you can use this state of the art, very few such across the world. You will be able to use this. And in India, this is happening not only in Andhra, but Bangalore is launching the Q City. They have also allocated land. They have also allocated, funds for this. So they are also launching quantum, systems and courses and many things. And across India, states are taking the lead. There is Maharashtra, there is Uttar Pradesh, there is Gujarat. Each one of them is now looking at how do we come and start building this capacity so that we are able to utilize the quantum computer Amravati so that we are that quantum advantage also. The goal here is for us to reach quantum advantage from India, to make sure that quantum does not only stay inside the laboratories, but it comes out of the laboratory and people can actually start using these systems. And today, there are multiple different use cases across industries which people are trying. In banking, people are trying fraud monitoring, risk simulation, customer analytics, all kinds of use cases. Automotive sector is also trying multiple use cases. Chemical sector, life sciences. And in Andhra, what is happening is the and the and the po- and the different offices in Andhra are trying to bring industry into the picture so that the industry comes and gives you these problems, says that please come and solve. These are the tough problems we are facing. We need these solved so that you then as faculty can go and solve these problems. You and your students can go and start solving these problems. That is really the goal. The goal is for all of you now to start solving these tough problems across domains like banking, automotive, agriculture. Please pick real problems. Please pick big. Use the quantum computer. Don't solve small problems with 10 qubits, 15 qubits. Solve the big problems using 70 qubits, 100 qubits. The best computers, you should be using them and solving the biggest problems. So that's the goal. That's what you need to be doing. You need to be solving the tough problems so that these tough problems can then lead to quantum advantage. Solving small problems, you will not reach quantum advantage. Quantum advantage can only be reached with problems which you cannot even solve on a classical best supercomputer. Those are the so search for these problems and figure out how can you solve them on the quantum computer. How can you get ready to use the quantum computer which is there? And remember, there is already free time that you can use on the systems, and that free time is more than sufficient for you to try and run certain mentioned here. Okay, now the other part, as I said, Amravati and in Andhra, you are also going to get hardware. Okay, so if you look at your today mobile phone, your laptop, any of these controlling the supply chain, China, USA, Taiwan, South Korea, and Japan. India is not there. India does not figure in this. But it is in work in these companies who are building chips, who are building the operating systems, who are doing this assembly, all. And hence, it is important that in the future, all of you help your students to actually build real things, hardware also, of course, focus on software, which is our strength, algorithms also, but also see what can you do in hardware so that your students can now go and start preparing these hardware components of the future so that the supply chain, India controls parts of that. That's the goal. We as a country need to be able to control these supply chain components running out of India here. In a quantum computer, there are multiple parts. There is the processor, the cryogenic amplifiers, there are microwave isolators, there are, cables, cryogenic temperatures, multiple things, then there is the control systems. So all of these actually need to be made. And now all of you, you've done these courses. The goal is for us now to get to do tougher and tougher and tougher things. Okay. So you please, if you are a algorithms person, focus on solving some tough problems in whether it is in chemistry, logistics, any of those. If you're a mechanical, civil, electrical engineering, also see how you can look at some of the hardware components. Some of the civil engineers now need to look at, how do you build data centers? How do you build cryogenic infrastructure? Quantum computers can be placed there. So all of these things, cryogenic temperatures are not only important for quantum, but they are also important in physics. They are also important in space. So in all these places, we now need to look at what are those problems we can solve so that we now are able to get in quantum supply chain in terms of creating products. Products can be, remember, both hardware and software. In software also, we need to think what are those products we can build here, whether it is for climate, whether it is for finance, whether it is for logistics. Pick one problem and try and solve it using a classical computer, using a quantum computer, and then see how the quantum results can be improved further and further and further in a manner that you are able to achieve quantum advantage. Question, what is molecular simulation? So molecular simulation, think of it in terms of a molecule like this caffeine molecule. It has several atoms in it. Now, if you wanted to represent the energy configuration of the caffeine molecule with, in terms of a fraction of a second, what you can build. The goal here is if you wanted to do that using the best supercomputer for caffeine molecule, you'd require 10 to the power 48 bits. And you can't even do that on a classical computer. You don't have a classical computer that big. So on a quantum computer, just 160 qubits is sufficient. Actually start building, molecular simulation use cases using a quantum computer like this. And the problem here is because we cannot simulate, today it takes us to find new materials. Think of plastic. Have you found a replacement for plastic? No. It has been several years. We've been trying. We are searching for new materials and we have not been able to find that substitute. Similarly, medicines. It takes us several years to come up with medicines because today we are not able to simulate, We take molecules in my test tubes, pour them, see how it is, how the disease and the medicine are reacting. Then once you think it's doing well, to mouse, you take it to dog, you take it to monkey, then you take it to human beings. And that takes several years. Okay. This whole process from mouse to monkey to human being. So now, if you were able to simulate this on a quantum computer, that time shrinks, shrinking of time happens. Okay. Similarly, cryptography, our encryption, which uses what is called prime factorization, factoring large numbers. That is what we use as our keys today. Very large prime numbers, you multiply them and you use that multiplied number as the key, because you cannot factorize it on a classical computer. But this can be done on quantum computer. I hope you learned Shor's algorithm. Okay. So you can actually do this factorization on a quantum computer. Now, you cannot do this on a classical computer. So here is one more example, right? Similarly, learning, AI. So today, as a child, your children, you teach them cat, dog, monkey, elephant. They require two examples. You show them one cat, and then next time cat comes. But for an AI system today, it requires multiple cats. Why? Because the classical AI systems today, the representation in zeros and ones, is not very efficient. And the quantum computer, we hope, is able to bring that closer. And that's why, if some of you are good at AI, it will be nice for you to start looking at quantum AI problems. Compare. Run on a classical computer, run on a quantum computer, see how you can improve both. And at some point, is the classical computer outperforming the classical computer? That's what you have to check. And now, are there any questions? What is the approximate cost of IBM quantum computer? The IBM quantum computer system 2 is about 600 to 700 crores. That's the cost of, think of it like 600 crores is the cost of the IBM quantum computer. Okay. So that's the approximate cost. How the mathematics background person can contribute. It is all mathematics. All this is all, whatever we are doing, linear algebra is the basis. Okay, so please, for people who are in mathematics, we really, really want you to, look at problems, because you will understand them faster than anybody. People who know, they will be able to pick this up faster than anybody else. Okay, so you will be able to do quantum computing much faster compared to people who don't know maths or physics. Okay, so if you are good at mathematics, I would I'm sure you ran through the QT courses. Now pick one or two problems and try solving them on a real quantum computer. You have to, you need, and that's why I said interdisciplinary teams. You need to have somebody in your team who is good at maths. You need somebody, if you're solving a chemistry problem or a molecule problem, you need somebody there. You need somebody who is also able to do the programming in Qiskit or in, whatever the quantum language. I hope you know that quantum programming language is called Qiskit, and Qiskit is Python based. Okay, so you can run Python programs on a quantum computer. So if you know a little bit of programming, you should be able to start using a quantum computer, running your programs on a quantum computer. And for you, the person in mathematics, I would urge you to either learn some programming yourself or join with somebody from the CS background. Two of you together, try and solve these whatever mathematics problems. In fact, you pick any problem and it has a lot of maths in it, and you can be that mathematics person. The other person can actually go and do the coding. Okay. So I would urge you to do that. So I'm going to stop here. Okay. And let's see if there are more questions. So any other questions that people have? Okay. Predictive. Yeah. So, how many people here are from computer science background? How many people from mathematics? And is everyone, I don't know if you can do thumbs up or whatever. Is that even possible? If you can, then please do a thumbs up in terms of. Okay, I see physics. Nice. CS. Okay. So, see, as I said, a lot of you from need to actually come together. That's when the magic starts to happen. When people come together from CS, mathematics, chemistry, civil. In fact, even in civil, there are uh, you know, how strong will your structure be? Structural beams and, bridges, all of these, because there is a lot of data available in terms of how the rivers flow, how avalanches happen, how climate change happens. And all of these, if you are able to work together with CS people who are able to do the programming, the civil person who is able to bring that use case, the mathematics person who is able to take that civil problem and convert it into a mathematical problem, real world problem, is a problem which, for example, it can be indigo, it has to send flights. Then somebody has to convert that into an optimization problem, and that's where the mathematics people come in. Okay, so the mathematics people take the indigo, whatever, aeroplanes, air pilot, uh, then there are all these airports, and take that and convert it into one mathematical problem. Okay, that mathematical problem, then the computer science person takes that and converts it into an algorithm or into a program which then runs on the quant computer. Okay, so if the three of you come together, okay, which is the civil person, the uh, uh, the mathematics person, and the CS person, then you will be able to solve things much faster, much more easily. You will be able to get results. Each one of you will be able to discuss and get it. Okay. I tried to solve of mechanical machining process and get the solution. Yes. And somebody has already given the answer, because it requires a lot of qubits. Okay. So please look for problems which today's computers can solve. Today's computers have how many qubits? 100, approximately, about 100 plus. Okay. So take problems where 100 qubits can solve it. That's what the is doing when they say quantum advantage. They are taking problems where they are able to solve that using the 100 qubits which are there on the quantum. That's what that problem selection is also important. You need to select a problem which you can run on the current systems, or you must be able to break it up into pieces One part runs on this processor, one part runs on that processor, one part runs on HPC, one runs on quantum. So you need to do that. Problem selection is also a very important thing. What is the approximate cost of, I don't know which cost you are asking here. So the IBM systems, you can please type IBM Quantum. It will take you to a website. That website has IBM Quantum system available online, which you can use for free. 100 plus qubits for free. You can use it today. Okay. The Amravati system, okay, that cost of such a system uh, is about 600 to 700 crores. That's the cost of the system which is coming to Amravati. Yeah, around saying that government is wasting money, they are spending too much. Because I see many people say that the government is not paying, okay, this amount. So you need to be, you need to get your facts right as to who is paying. So this is not public money that the government is taking and saying, okay, now we are putting 600 crores, which we will, instead of building a road, we are going to buy a quantum computer. So I see many people running those kind of arguments also, but this is not that. Okay, so please don't say that. I mean, I'm not saying you are saying this, but there are people who go around saying that government is investing billions. Actually, government is a facilitator. It helps people to come together and invest and work together. Yeah, obviously, the quantum computer cost will come down. In fact, just like the classical computers, the cost keeps coming down. In fact, your own mobile phone, every year a new mobile phone comes out, the cost remains almost stationary. But what changes is that the same components which are used in your mobile phone, the chip, the camera, the screen, all that, the cost keeps going down. So, as quantum computers become more and more used, as more and more people start to use them, and as you start producing more and more quantum computers, the cost will start coming down. Okay, so if there are no questions, so thank you so much. So, sir, I think we were going to a ceremony, is what Billy sir mentioned.
Thank you, sir. Thank you very
Yes,
much.
sir, Anil sir, please.
I request any participants, do you have any questions? Otherwise, we can close this session by thanking today's resource person. Sir, today's your talk is very exclusively on the different initiatives. Really very good, and everybody got to know that what is going to be happening in Amravati Quantum Valley. For this insightful talk, really, I would like to thank you very much from all our faculty and also AP State Council of Higher Education, MIT. And sir, most of our faculty members are really seriously engaged in this FDP program. And not only that, our students also throwing a challenge for our faculty members because they are coming up with this, very innovative ideas. Even they are working on different algorithms. So it is a win-win situation for both the faculty as well as the students. It's all just because of inspiration by you. When you written the book, that is Quantum Nation, it inspired everybody.
Thank you, sir. Thank
And
you.
it is also a user-friendly book also. That's why everybody connected and everybody read that book. Now I hand over this to Emmanuel sir, Dr. Emmanuel sir.
Yes, yes. Thank you, Venkat sir. Thank you for your time and thank you for being there. I just reached the airport and I'm just about to take my flight to Hyderabad. So for a meeting in
Okay.
Triple IT Hyderabad. So that's it. So I think the participants will give some feedback, sir. You can stay for some time in case you are free.
I think
Then
sir
we'll
also got some
conclude
meeting.
because today,
Yes, yes, I'm free.
yeah,
Yes, sir also.
today is the last day.
Yeah.
Sure, sir. Thank you so much.
Okay, sir.
No,
So
thank you,
maybe we
sir.
can ask participants, Anil sir, we can ask the
Yes,
Yes, yes, yes.
participants,
Yeah.
uh,
Sure.
what they want in the course, what are their expectations, going forward. How do you think it will be easier for you to teach these courses? Because honestly, the goal of all these sessions is for you to go back to your students, do projects, do teaching assignments, all of those. So how can, is there something you would like, because Anil sir is here, he can try and implement some uh, in the colleges.
Sir.
Yeah, participants may have one question, which usually is the when will be the quantum QT-01 and 02 sessions, which they miss. That we'll conduct in the month of April, the third cycle, let me put it that way. MNIT cycle has happened, APSCHE cycle is now going on. One more cycle will start in the month of April. But till that time, the sequence will continue. Now, 6 will start, QT-06, 7 and 8 will complete by March. April onwards, QT 9, 10, 11 will start. Along with that, we'll start QT-01 also. Apart from that, if you have any questions, please post in the chat. We'll be very happy to answer.
We lost you, sir. Are you there?
Yes, sir. Yes, sir. I'm there. Yeah, they can post in the chat. I'll be
Yes.
happy to. We
So
can take
I'm
the.
going to read a few questions for you, sir. Okay. One of
Sure, sir.
them is, sir, for beginners, what is the roadmap of quantum courses specifically for UG students? So I think three courses are there. Okay. So for UG students only, this QT 001, 02, 03, 04. It's in a sequence. Okay. For UG students, this is the sequence. In addition to this, the Andhra government is also doing the WISER, the NPTEL, all these courses, okay, so that you are able to not only get your students involved in the QT courses, but also get this extra, um, courses like WISER and NPTEL, from where you can actually take credits also into your engineering program. Okay, so many of these courses are there for beginners only. If you just follow the sequence QT 0001 02 like that, that is the roadmap basically. More hands-on sessions are required for practicing. We are looking for some platforms for practicing. So on this one, I will, if Anil sir and Emmanuel sir, before they answer, I would like to say that on your, there is a free platform. You go to something called Qniverse, QNIVERSE. This is from CDAC, okay. Then there is IBM Quantum. Okay, you go to IBM Quantum. All these places, you have access to free quantum computers. Okay, you can just go and start using real quantum computers at these places. Okay. Now, in these things, there are also, you go to YouTube and say, how do I implement something? Or you go to GitHub, how do I implement some algorithm in, let's say, logistics or optimization? You can just type those kind of code are already written on GitHub, YouTube, you will find them. So please just go to that, download those things. It will, in 2 days time, you can easily start doing some of these things. Very much hands-on. And I'm sure Anil sir and Pilli sir will take this as feedback that in future we should have more hands-on sessions. But they are also trying to balance between theory and practice. Okay, the practice part, it's very difficult for them to open up a editor here and say that okay, now type, go to, I mean, whatever, start the circuit, import this package. If they start doing that, then you will lose interest also. So for that, please go to YouTube, please go to GitHub, just get, there is lot of code, there is lot of recipes which are there, and you can get started. So after every class, please go and write at least 50 lines of program, so that you yourself will then start feeling that I'm now able to write a program myself and I'm getting this hands-on training. Ashwath sir, you are also here. You can give us some answers to how do people become hands-on, and how do people, uh, what is the sort of the roadmap? So of course QT itself is a roadmap, but how do people become hands-on? Can you give sort of a roadmap? Because I know you've been teaching students for a long time now. In fact, not only students, even practitioners.
Sir, yeah, definitely, sir. It's a very good question to be asked. So some time back also the participants were asking. So one easiest answer would be like as of now, uh, on cloud the simulation softwares are available. So in a way, it will not give a full-fledged hands-on experience, but thanks to the DST with the NQM, they're establishing undergraduate labs. So we were also given a chance. So we will be asked to present our proposal very soon. So there, like what I heard is some 100 labs will be established throughout the country, undergraduate labs. So the participants can either get in touch with those in the lab, the hubs, sorry, lab hubs established nearby, and they can go and have like a weekend or something, a hands-on experience, right? So that is possible. Until now, that was not at all possible because the only way is to do either do cloud or go to research hubs like research centers where there is actual qubit realization, that to a very limited extent in our country. But like ISC, IIT-AFR, IIT Bombay, or IIT Madras, they have some sort of facility, but they may not extend for the hands-on experience for the participants. So I like right now, answer to your question, sir. It is going to happen very, very soon, sir. So just wait for some time, maybe in 6 months or so. Some very early stage, the basic quantum computing or quantum qubit realization experiments will be set up in at least 100 the labs at the institution across the country. So yeah, I heard some from Bangalore, some of them who approached me earlier for the discussion on the lab proposal, they got, and they were asked to present. Similarly, we were asked to present. So it will be very soon will happen, sir. That would be a good option to get actual hands-on experience other than cloud.
Okay, there is one question here, which is there a fully remote online quantum computing master degree available from any university for working professionals?
Master's degree, sir, as per my knowledge goes, not yet, sir. But there are certificate courses from IITs, IIT Madras, and CDAC, ISAR Pune. There are certificate courses, but BS plus MS courses are there in, I think recently started in ISAR Pune, sir. MS course is started. So
But it's not online, no, sir?
no, no,
Online,
no.
they are suggesting, Dr. Ashwath sir,
Uh,
there is no online course as much as I remember, but there are certificate courses. IIT Delhi offers it, and there are other, but
Yes, sir.
it's a 6 months course. Degree, online degree as such is not recognized very much in India.
Yeah.
So I'm sure it will
I
take some
think,
more time
yeah.
before,
So
yeah.
it will be too early to say something from our institute. I think there was some discussion earlier, sir, on such thing, because our institute already floated two MTech courses online. One is data sciences. Other one is very soon coming in cyber security. So during that, I think quantum technologies, that one more was being discussed. So it will happen later stages, but it is there. But when during that we had a discussion, is there any anywhere it is offered? Like Billy sir mentioned, as of now in India, no sir, nowhere,
Yeah,
nowhere.
and I think the thing is that, remember, quantum has two aspects. One is the algorithms aspect. The
Correct.
other is things like hardware. Okay, so which could include sensing, materials, all of the hardware aspects. Now, algorithms, yes, it is possible for you to teach online and all of that. And when you say hands-on in algorithms, please, I hope you are all taking these courses and then going to YouTube or GitHub and actually practicing on a real quantum computer. Okay. But then when you go to hardware courses, whether it is sensing, materials, in all of these, that's the one which, Ashwath sir is mentioning, that the government is going to set up 100 labs across the country in all the states of India. There will be labs. And those labs are what we will have as places where students could sometimes go and learn a few things, maybe see actual optical experiments and all those things. But remember, for hands-on in hardware is harder than hands-on in algorithms. So people who are from mathematics, physics, who want to do algorithms, please get started. Don't wait for anything, because you already have whatever you need for hands-on. For others who want to do hardware, yes, there is some waiting, but even there, if you write to, let us say, some professor in ISC Bangalore saying, "Sir, can I visit your lab?" They're not going to say no. Nobody will say no in today. Okay, they will all. In fact, Ashwath sir, I'm sure you have some labs which you will also be happy to open up to people who come all the way. So each one of you, please reach out to people if your interest is in hardware. There also it is possible to do hands-on things. Okay, any other questions? I see no more questions here. No new questions. Did I miss any questions? Okay, somebody says we need a course in predictive management. Yes, I'm sure we need. In fact, we need quantum management also, because a lot of today, you know, technical people go and start solving problems. You give them a problem, they start solving it. But what is the roadmap? If you are a bank, what should be your roadmap for adoption of quantum computers in the next 5 years? So that is a management question. Okay. That is not a technical question. It's not, you ask a technical person, he'll say, "Oh, go do fraud management, go do this." They will give you all the technical problems there. But as a bank, the bank has to think, today I have personal banking, I have corporate banking, then I have mutual funds, some N things I have. In all of this, in the next 5 years, and remember, these are the questions which were asked 20 years ago when computerization happened. The banks were asking, okay, how many clerks should I fire? And what should I do? How much should I go online? Should I make ATM? Should I? That was all the computerization time questions. Now, same sort of questions are being asked in the quantum era. Indigo is thinking, oh, can I now, this problem which I had last month, if I had used a quantum algorithm, could I have solved it? Should I now be exploring quantum in the next 5 years? so that such problems don't come again and I'm not fined. Okay, so those are the questions which management people need to answer, and those kind of courses are also very much needed. And in Andhra, I don't know if you've heard the chief minister, one of the things he keeps saying is one entrepreneur per family. And that one entrepreneur per family has to be somebody who is starting a startup, somebody who is starting something, uh, a new MSME, trying to give jobs. That's what this is. And it's very important to do these management degrees where you are integrating quantum into it and sort of providing a plan in terms of how we should.
Satyendra, or any other you can read, maybe sir or myself, we can answer. Otherwise, we can go ahead with the participation feedback. Dr. Satyan?
Sir, I'll go myself, sir. Please, sir. Shall I?
Yes, sir. Go ahead. Go ahead. Yes, please.
So I'll go from now to back so that we will reach to the point where Venkat sir was answering. Okay, there is a question here, sir, by Rajkumar ji. Please suggest us to do PhD in quantum technologies in upcoming year. To do PhD in quantum technologies. Okay. So if you are already a working professional, there are possibilities to pursue PhD part time across various institutes, right? So there is you want to pursue at premium institutes. Some of them allow, for example, I think ISC allows as a quality improvement program. You need to check. But other than that, the institutes NITs and triple ITs, they do offer a part-time quantum computing technology PhDs. Otherwise, if uh, your employee allows you for 3 years or so, then it will be a good option to look for PhDs in the premium institutes and universities. So that would be a very good choice, right? So in the upcoming technologies, one choice you could choose is quantum communication. That is the one which is being giving or uh, has a potential to give the immediate results, the quantum communication. So that is where you can work. Or if you want to work on some computing case, algorithms like Venkat sir was mentioning, that is the one immediate thing. People are working on algorithms, right? So please look for the LinkedIn post by the Quantum Hubs, NQM National Computing Hub, National Quantum Mission Hubs. They do share their calls for the PhDs and even for project associates and even for collaborations. They are doing advertisement. Please look for it, so you may get some start from there. Okay, so let me go back and see if there is any questions. Yeah, definitely we need to have serious amount of patience and practice as well. Okay, we need to do to get better in this field. Okay, so is there okay, Yugesh ji is asking, is there fully remote online quantum computing master degree
Sir,
available from any use? Yeah, I think this
Ashwat sir,
question.
just Ashwat sir, just let me add that PhD question.
Yes, sir.
MNIT offers executive professional for industry professionals.
Oh,
So
super.
that is one option. And as you mentioned, part-time sponsored is there. Full-time programs also are there. Now the scholarship is good enough. So 37,400 is the scholarship amount. Plus HRA is about 16% of that. So somebody gets about 45,000 to 49,000. That's a good salary if somebody wants to really look at. I will be offering quantum computing. So any area we can decide later, but quantum computing is a broad area of research. Yeah, thank you. Yeah, please go ahead, sir.
Yes, sir. That's a very good thing, sir. So somebody who actually able to move to full-fledged PhD. So like sir was saying, very good salary, close to salary, I would say, the stipend. So yeah, if you happen to have some very good fundamentals, then you can appear for GATE and CSR. So if you have a clearance from there, you will get a good stipend there. And let's say for women, there are scholarships for them for pursuing PhD, let's say WISE fellowship, and those options are also there, right? So there are quite a few. There is a INSA fellowship for PhDs, and even for postdocs, it is there. People can explore. Yeah. So yeah, once again, I think we have reached to the point where the discussion was happening with Venkat sir. That is a master's program online. So it will happen very soon, but as of now, the certificate program courses are there. So in a way, with the existing situation, I think certificate courses are pretty much very good actually. For example, you get a certificate from IIT Madras on particular area in, let's say, content computing, then it's like reasonably good. You can project yourself as a qualified professional in the field with that certificate. Yeah. Yes. Okay, sir. I think there were no questions. I think before that, I think the questions were already answered, I guess. Yeah.
Yes, sir. Dr. Satyan, we can enable the participants to share if anybody would like to give feedback on the course. Dr. Venkat is there, Dr. Anil is there, our resource people are there. Mr. Raja Singh Yadav from CDAC has joined. Venkat, sir, I would like to just add that you mentioned Qniverse. This time we had demonstrations on Qiskit and Qniverse for four sessions, sir. That is 8 hours. All algorithms were demonstrated. So Mr. Hari Singh Yadav from CDAC had given the demonstration. One more person was also there. So they had given Jaykumar Vedkashankar, Dr. Jaykumar. He gave simulation code on Qiskit. Dr. Satyendra, over to you.
Yes, sir. So any participants who wants to give feedback can raise their hand so we can unmute you. So let me check. Any participants who wants to give the feedback or say something about the course, just raise your hand.
Okay,
so
so there
we
is
can
one
unmute
more.
you.
Somebody has asked one question here. Any PG scholars can do PhD in QT, sir? Yeah, I think any PG scholars can do. Or is there some constraint that only some branches can apply, or?
Sir, when you want to do PhD in computer science, there will be certain restrictions of sciences degrees, like master's degree in science and maths. But some courses like artificial intelligence and data engineering and wherever AI courses departments are there, they are offering even PhD courses eligibility for master's degree. MSc Maths and MSc Physics can apply. So please look up universities, and I think maybe and Dr. Ashwath may also throw light. Like ISER definitely will allow a PhD in quantum with MSc Physics or MSc Maths background.
Yes, sir. Definitely, sir. Just to add a small addition there, sir. Let's say it's completely out of zone. Let's say you are coming from, let's say, commerce and somewhere at a bachelor's level or a master's level. You want to pursue PhD in quantum. So in that case, you may try to connect your background to the quantum computing, maybe optimization level, algorithm, something of that sort. So you may not be able to go into the hardware experimental realization of quantum qubits and so on. That may be slight tricky because it needs some college level foundation from the physics side or engineering side. So that may be a issue. But for example, let's say you take some IBM professionals from US. So people who have commerce bachelors, and they also did a PhDs in quantum computing or quantum technology. So that kind of a flexibility is there in US and Western countries, but we yet to reach that level. But having said that, there is a possibility to even jump over. Uh, so only thing is we have to give a justification. We have to see why the jump is needed, and even in a reasonable manner. You can't jump, close your eyes, and jump to anywhere you want. It's not like that. So make a constructive jump. That is possible. Accordingly, you can plan. So yes, this is a particular area. Quantum technologies, quantum computing is a multidisciplinary area. There is a provision for anybody to get into the field. So only thing is, in a right justification, a right manner, you can pursue it, right? For example, in our institute, like 4 or 5 years back, it was very rigid. So for example, somebody who wants to pursue a PhD in, let's say, computer science, let's say in computer science, people from electronics with a bachelor's degree and master's degree, it was little bit tricky at that point. So even MCA candidates were not allowed to do a PhD. Something like that was not earlier, but that is now eased up with uh, this new education policy. So anybody should be able to do and study in any field. So every institute is opening up. So I would feel you can definitely approach to whichever institute, premium institute or institute you wanted to pursue PhD. You can approach the faculties there, which you feel like very exciting research they're doing. So you can look for the options and find out the paths to get into the research. So that flexibility is there as of now. Okay, right? Yeah.
Yes, so one participants have raised hand. Mr. Rajkumar Gunti. Uh, I
Sir, good
request
evening, sir.
coordinator.
Good evening,
Yes,
sir.
yes, please.
Sir,
Yes,
this
please.
QT-05 quantum competition is really excellent, sir. Lot of focus you have given on hands-on practice, and I am so happy for that. Especially Aswat Bab sir, Jai Kumar sir, and Ritajit Majumdar sir, and Harishankar Niyodit sir. All these people, they really focused very good on this competition, quantum competition. Actually, I feel some of the classes, because I have many interviews in this month, especially IIT Dhanbad and other MSME technology and Deputy General Manager post, I could not able to concentrate in all the classes. Still, when I am attending, I could understand really it is very practical approach, this QT Pfizer. I'm so happy for that. Thank you very much for your support in this QT Pfizer. Even I'm thanking to Venkat Subramaniam sir also, Raja Singh sir and Emmanuel Subakar sir for your suggestion and
Thank you,
guidance.
Dr. Raj.
Thank you, Rajkumar ji. There is another participant, RVS Lalita ji is there. Please
Sir, namaste,
go
sir.
ahead.
Sir, the sessions are very good, sir, by Asad Babu sir, Jay Kumar sir, and today LV Subramaniam sir, and all the resource persons are very much. All the sessions are very good and very informative and excellent, sir. We don't get this sort of these resource persons anywhere, and the material you are providing in the canvas It is very helpful, sir. Even though we miss one part of the session, we can refer from the canvas and we can look into that information whenever we require. Thank you, sir. Thank you very much for arranging this sort of sessions. And I thank all the resource persons for explaining us a very tough topics in a simplistic way, sir. Thank you very much.
Thank you, ma'am.
Thank you, ma'am. Thank you.
Thank you, sir.
Any other participants who wants to share their feedback about the course, about the content, about the organization of the course, anything? There's one more participant have raised his hand, Dr. Ramanna. Yes.
Sir,
Yes.
good evening to all, sir. Sir,
Yeah.
is audible,
Yes,
sir?
please.
Yes,
Yes, audible.
Sir, first of all, I want to thank you, Academy, EACT Academy, Subramaniam sir, Ashwath Babu sir, APSCHE, all are very doing very good efforts for the enlightenment of these quantum technologies. So that this course is very fine and easy to understand. Especially the level of course is easily understandable. Thank you, one and all, sir.
Yes, Chandrasekhar ji. Yes, Chandrasekhar ji, please. You can unmute yourself and speak.